there. Today we're doing the last lesson of Chapter 4, Advanced Trig Problems. We're going to look at some identities and do some more advanced problems with the identities. We're going to do some solving triangles, but more advanced versions, some applications of SOHCAHTOA kind of stuff. We're going to start with some identities here, and these are identities we've already talked about, but we're just going to review them, do a few harder probably types of problems with identities. This is going to be on your test again, and it is all of Chapter 5, so we don't want to forget how to work through these. These identities right here are the ones that you have to know. I will not be giving those to you. I got to think we know these inside and out. Maybe take a glance at those and remember that tangent is the sine over the cosine versus cotangent, which has cosine over sine. I will go ahead and give you the Pythagorean identities for this test, but this will be the last time. After this, you'll have to know them. And in general, you're going to need to know them because when we're working through problems, if you're not familiar with them, then you don't really see what's happening on your problem to know what to do. You've got to be very familiar with these. So hopefully, maybe some of you already are. Now, I went ahead and gave you a hint on this one, but I won't be doing that on the test. Here's the deal. I'm going to give you sine of theta, and that's going to be negative 5/13. And then I'm going to tell you that theta falls between pi and 3 pi over 2. We know that the reason I'm giving you this is to tell you what quadrant I'm going to be in. So theta falls between pi and 3 pi over 2. That is in quadrant 3. And then we're looking for the value of the tangent of theta. All right, so I'm not really like typing tangent into my calculator. I'm using my identities to somehow get from a sine relationship to a tangent relationship. This says try using a Pythagorean identity, then a quotient identity. Okay, well, I can't really use the identity that where tangent is sine over cosine because I only know sine. I would have to know two things. I'd have to also know cosine, and I don't. So my hint is to go to that Pythagorean identity and then do the quotient. If you go to your Pythagorean identity that links sine to cosine, that might be the trick we need. So on your test, remember I'm looking for some nice work. Let's start, so I know what your game plan is. Let's start by writing which identity you want to use. And then replace your sine squared here with negative 5/13. That is going to be squared. We do not know what cosine squared is. That's what we're going to be finding. It's going to equal 1. Now, I'm going to plan ahead on this. I've done it enough times. I'm going to plan ahead. I know that I'm going to end up having to bring this over. And this denominator is going to be 169. So I'm going to write my 1 as 169 over 169. And then this is 25 169. So I'm going to subtract the 25 169 on both sides. Okey-doke, that's gone. I have cosine squared theta equals 169 minus 25 would be a 144 over 169. Let's square root both sides. That works beautifully. So cosine theta is going to be a plus or minus 12/13. However, it's not really plus or minus 12/13. You have to make a distinct decision on is it plus or is it minus? And that has to do with this right here. I am in quadrant 3. And in quadrant 3, cosine is negative. My official answer then is that the cosine of theta is a negative 12/13. Now that's great, but not what they asked for. They asked for tangent. But remember what I said, you can now do your quotient identity because you have both sine and you have cosine. I'm going to begin by writing the identity that I'm trying to use. So tangent of theta is equal to sine theta over cosine theta. Now let's plug in the numbers. We've got a negative 5/13 divided by negative 12/13. Pop this up and multiply by the reciprocal. Okay, this is going to work great. 13s cancel, negatives cancel, and I have the tangent of theta equal to 5/12. And that officially is what I want. Notice the organized work. That's going to be important that I can track what it is you're doing. These are not drawing triangle kind of problems. This is using your identities. Practice with those. Let's take a moment here to review some SOHCAHTOA rules. A lot of what we're going to be working with today is this. We're just going to do a lot of applications with it. So real quick, let's go through one problem here, just a basic. SOHCAHTOA says solve the triangle. Means I've got to find all the missing parts. When I look at this, I can see that I am missing angle A. So I'm going to want to find angle A. I want to find little b, and I want to find little c. I'm going to start off with angle A. Since I have a 90 and a 25, I can subtract from 180 pretty quickly and find out that angle A is 65 degrees. I have already done all the computation here, so I'm going to hurry this up. Maybe you're going to love that because you don't have to mess around waiting and typing stuff in the calculator. Or maybe you prefer to, then you have to pause the video, I guess. Let's go look for little b. I always want to use the information they gave me over information that I find, if at all possible. If I goofed this up and then went and used it, I know nobody ever thinks they're going to goof it up. It seems easy, right? But people do, and you might be one of them sometime. Use what's given. That won't be wrong. Now, I have given this 25-degree angle, and I've given this 8. This 8 is adjacent, and then I want to find B and C. With adjacent, I'm going to go ahead and start with my B. That's opposite, which trig ratio uses opposite and adjacent. The answer is tangent. I'm going to write tangent of 25 is equal to opposite over adjacent. That's a quick, easy, just multiply both sides by 8. And one of the things you might want to make sure is that you're in degree mode here today. Everything's going to be degree angle measurements. I ended up with a 3.73 when I typed that in. Notice the units on this, so it is meters. Let's try one more. I've got to figure out the C. So what I was talking about earlier, I would rather you not go do Pythagorean theorem now that you know two sides and you're looking for the third. Again, well, first of all, this is rounded, so if you did do that, you better be using full values, not this rounded value. And again, if this is wrong, then that's not good for the rest of the problem. So you do you. Next one, I'm going to then use this 25, this 8, and this C. This is adjacent. This is hypotenuse. That should be a cosine problem. Cosine of 25 is equal to the adjacent over the hypotenuse. Now this is a little more complex situation because I have to multiply both sides by C instead of multiplying by a number. But maybe you've done this enough times, you can kind of do this in your head and you can see how this is going to play out. You're going to end up taking your 8 and you're going to divide by the cosine of 25. I got little c to equal, I'll just go ahead and write it up here, 8.83. Do a quick glance to make sure this makes sense. Is your hypotenuse the longest side? It is. All right, let's keep going. Now let's look at some applications of SOHCAHTOA. One of the things that is tricky with applications is this whole angle of depression. Angle of elevation is no big deal. It's like you would think. I'm sitting in a car. I know they're turned backwards. Let's pretend they're looking this way up at the sky. This right here would be considered the angle of elevation from the driver looking up to the top. That's his angle of elevation. However, when I'm dealing with this triangle right here, and perhaps this person is looking down at the car, so now you're talking angle of depression. It's so tempting to make this be the angle of depression, but it is not. You are always going from line of sight. So when you're way up top, your line of sight is way up here, and then you are looking down. That is the angle of depression. That's the 30 degrees. Now, I don't know what your teacher necessarily taught you, but I feel like by the time we're at this level of math and you've done SOHCAHTOA enough times, I think it might be nice for you to recognize a handy feature here. This whole thing with angle of depression is kind of a challenge because that's 30. It's kind of a challenge. It's not terrible because what we do is we just subtract from 90 and then we'll know this angle. But let's take a flashback to geometry. Remember the whole parallel lines cut by a transversal and you have all those angle pairs? Your alternate exterior angles are congruent, your corresponding angles are congruent. Well, what I want to draw your attention to is the alternate interior angles. Remember that the alternate interior angles, this one right here and this one right here, are congruent. And that's what the picture that actually gets drawn when you have this scenario where you have the right triangle and then you draw this line of sight. I have my parallel lines cut by my transversal. If you'll look here, my angle of depression here is an alternate interior angle with down here at the car. I have them already marked, but that's what's going on. These angles are congruent, and that's why I'm making these angles congruent. So futuristically, if I tell you here the angle of depression is 30, and you instead of putting it here, choose to put it down here, that'd be okay. It saves you just a little piece of subtraction here, and maybe it just depends on what else is going on in the problem. Here's one of our more challenging types of application problems. The angle of depression from the pilot's point of view to the close end of the runway is 62 degrees. I'm going to draw myself a little triangle here. Pilot is looking to the close end of the runway. We have that. And the angle of depression from the pilot's point of view, so that means this is 62 right here. Now I can subtract from 180, subtract from 90 to figure out this angle, or if I wanted to, I could just put the 62 down here. I might do that since we just talked about it. Let's keep going. The angle to the far end of the runway, okay, so that's way out here. And now it's this angle is 54. And instead of putting the 54 there, I could put the 54 down here. If the plane is at an altitude of 2,000 yards, how long is the runway? Okay, so the problem that I have is that the runway is this chunk right here, but that is not really well, maybe I should say this. How many triangles do you see in this? There's this one, and there's this one, but there's also the big one that incorporates both of those. Now, only 2 of those are right triangles. So the runway happens to be a side length of this triangle, but this triangle is not a right triangle, so I can't do SOHCAHTOA on it. What that means is I'm going to have to look at the big triangle here because it is a right triangle. And those are going to be, I'm going to have the black triangle there, and then I'm going to go ahead and go over this, and then I'm going to have the big blue triangle. I'm going to go ahead and find this measurement because I can do that. I can also find this measurement because that's the side of the black triangle. And what do you think I need to do then to find the full answer, which was how long is the runway? Yeah, I'm just going to subtract those 2 numbers that I get. Let's give it a shot. I'm going to call this X right here. This is my X. And then I'm going to call this my Y. Let's start with X. I have this 62-degree angle. I have the opposite, and I'm looking for the adjacent. That is a tangent problem. Tangent of 62 is equal to opposite over adjacent. Multiply by the X. come back and divide by the tangent of 62. All right, I'm going to come back and do that. I don't have my calculator ready to go. I'm going to keep moving here. Now I'm going to do the blue triangle. And again, I'm looking at this big one, and I've got the 54. I've got the opposite, and I'm looking for the adjacent. Just a same deal. Tangent of 54 is equal to 2,000 over y, multiply by the y, come back and divide by the tangent of 54. All right, here we go. I'm going to type these two answers in real quick. I'm going to do that one right now. 2,000 divided by the tangent of 54. All right, I'm getting 1,453.09. Now I'm going to do the other one. Take the 2,000 and divide it by the tangent of 62. And I get 1063.41. And then we said, if I subtract those, because y is too long, so if I subtract x from the y, what I have left is the runway. And I get 389.67. And we are in yards. I don't know if that's realistic or not. I'm not a pilot, but let's hope so. 3 football fields, almost 4 football fields. It's a small plane. It'll be fine. The next type of application involves direction or navigation. And this might be kind of new to you. Maybe you've talked about bearings in physics, maybe not. Maybe we've talked about it enough. It does come up when we do arc length. But bearings can be written several different ways. And I want to kind of show you a new way of showing bearings that you're going to see. They're used to indicate navigational angles. You only do this if you're doing navigation, planes, ships, that kind of thing. They're not the same as our directional angle. That's our math angle that we will have to be able to convert between the two types. To do math, we think unit circle angles, not the same as navigational. Now, previously when we did bearings, everything was based off due north. Now we're going to open up that a little bit, and we're going to allow ourselves to sometimes work off of due south. And where are you in reference? Are you more north or are you more south? And where are you from that? So the bearing in this case is always going to be an acute angle, less than 90, formed either east or west of the north-south line. So where are you in reference of the north-south line? Let's look at this example that I have here. This one shows that I am 78 degrees east of south. This is the way it looks. You kind of indicate that I'm using the south line, and then you're 78 degrees east of that. So here is due south, and I am 78 degrees east of that. Could you turn that into a math angle if you needed to? Well, sure you could. The math angle is this one right here. And it goes around like that. That's the math angle, like on a unit circle. And there'd be different ways to do this, and what you do doesn't matter. Maybe some of you would look at this as like, that's 270 plus another 78. Or maybe some of you would find this little gap angle in here. To find that little gap angle, I guess you'd have to take 90 minus the 78, and that'd be the leftover piece. And then you could do 360 minus that little leftover piece. That seems like a lot more work than what the first option. So I'm going to go with my first option. I'm going to take 270 plus 78. And so the directional angle would be 348 degrees. We're going to practice that just a little bit here to make sure. I feel like these are easier bearings than the previous version because if you just draw it out, it's pretty straightforward. So 25 degrees east of north. I'm going to draw it out. Here's my compass rose. I'm more north, but I am east of north. So I'm really going like this direction. And I am 25 degrees east there. So if that's a 25, this might be an example where then I'm going to go convert. I'm going to find this gap angle here. That would be 90 minus the 25. So that's going to be a 65-degree angle. And there's my acute angle. It's my math angle. I would say 75 degrees. Let's try another one. This one, we're going to be more southerly, but we're west of south. So, and quite a ways west of south, where this is 85 degrees right here. Now we want to do the math on it. The math starts over here and wraps around to there. I can see that it's 180. Do you know what this little gap right here would have to be? Yeah, it'd just be 5 degrees, wouldn't it? Because you've got an 85 plus another 5. There's your 90 degree. So it's going to end up 185. Next one. Let's go the other direction because once we do the math, we have to report back in bearings. Oh, I'm not very nice on this one. 139. Let's see what that looks like. Now this is a directional angle, so I'm thinking unit circle. 139 is somewhere like right here. There's my 139. What does that look like in bearings? Well, am I more north or more south? Okay, I am more north. So then I indicate that I'm going to use the north line. And then am I east or west of that? Well, I am west of that. And the question is, how far west? How far west of due north are we? Well, maybe it helps that I drew that second arrow. Ultimately, all we got to do is take the 139, subtract out the 90, and what's left is this piece right here, which would be 49 degrees. So we'd put in a 49 right here. All right, why don't you try this next one all on your own? Come back when you're done. Pause the video. All right, so here's my picture. I drew the 325-degree angle, and then I can see it landed down in that fourth quadrant, which means that I am going more southerly, but I am east of south, and I've already done the math on it. I just took 270. Actually, I took 325, subtract the 270, and I have this little gap angle of 55. So I am 55 degrees east of south. Now, let's do a problem where we have to use that. All right. This one, I feel like the drawing the picture is maybe the hardest part. The math maybe isn't terrible, but you have to be super accurate with your drawing for it to make sense. I tried to draw us a little picture to help us. So the boat is leaving the entrance to a harbor, and he's traveling 25 miles on a bearing of 22 degrees east of north. If you just think of what that means, you're ultimately headed northeast. But you're only 22 degrees. That's really not very far east. So I'm going to go like that. So I'm going to come out of this harbor kind of like right this way. Now, the captain then turns the boat 90 degrees clockwise. So boom, 90 degrees. And he travels for 8 miles. Now, if you think about this, this is 8 miles. He originally went 25 miles. So that should be a lot longer than this next one. So I'm going to quit right there. And I'm going to hope my picture is kind of accurate. Here's my right angle. I'm going to go ahead and finish this out. It's going to look like that. It says, how far is the boat to the harbor? All right. Well, I currently know that this is a 25 and that this is 8. And I could just do a quick little Pythagorean theorem to find out the third side, which is the distance to the harbor. So I should have mentioned, like, this is where the boat is right now. And then I automatically drew it back to the harbor, but I didn't really explain why. Let's do some Pythagorean theorem. Got my 25 squared plus 8 squared and square root that. All right, and that is a 26. I guess I should have shown my work on this. So that's 25 squared plus 8 squared equals x squared. And I got it to be 26.25 miles. All right, the next one is a little trickier. What is the bearing of the boat from the harbor? So from the harbor, where is the boat?